Okay, this is your chapter 4 textbook on fractions, decimals, and percents. So the first chapter, 4.1, show you knows. There's 3 different show you knows here. And really what you're trying to do is you're trying to give either a fraction, decimal, or percent. If you're given one of them, either a fraction, decimal, or percent, you should be able to convert it to the other 2. So in the first set of questions, you have fractions, and you have to convert them to both decimals and percents, okay? So if you're given a fraction, you should be able to convert them to those. So the first thing is taking this 3 out of 40 and converting it to a decimal. And I think most of us know that the easiest way to convert any fraction to a decimal is to take the numerator and divide it by the denominator. So if I take 3 and divide it by 40, I'll move this down a bit, I guess right here. 3 divided by 40 and press equals. I get 0.075, okay? So the first thing is changing it to a decimal, and that's how you do it, all right? Now the second part, changing it to a percent, once you have it as a decimal, the nice thing about it, if you know your place value, is you can read that decimal and write it as an equivalent fraction. So in this case, if I was to read it, I would read it as 75 thousandths, right? And I know it's thousandths because it's tenths, hundredths, thousandths. So if I covered up the decimal, if I was to just cover up the decimal, or erase it in this case, and read that number, that would be 75. And then if I look for, so then I write 75 because that's what the number is. And then I count the place value. So it was tenths, hundredths, thousandths. And that would be my bottom number, thousandths. So therefore, I would write it as a fraction of 75 thousandths, or 75 over 1,000. Okay. Now once you have it written as you read it, you will always be able to convert it into another equivalent fraction with 100 as a denominator. So in this case, because I have thousandths, in order to maintain equality, if I was to divide this by 10, I would create that 100 denominator, which is what a percent is. A percent means of 100. It's French. So if I divide the denominator by 10, I'd have to also divide the numerator by 10, which means an equivalent fraction would be 7.5 out of 100. Now, we're not making really an equivalent fraction because typically if you wanted to make an equivalent fraction, you would never have a decimal in your numerator or denominator. But the reason why we do is because now that it's out of 100, I can then say that this is 7.5% because it's out of 100. Okay? So that's one way to do it. So one way to do it is simply read it as a decimal and write it as a fraction, and then write an equivalent fraction out of 100 to get the percent. In the second example, B, there's another way you can actually do this. So for 171 over 300 here, I can actually figure out that I know that 171, the number 171, has 3 as a factor. And the reason why I know that is because 1 plus 7 plus 1 equals 9, and 9 is a multiple of 3, and we learned through our divisibility rules that that's what you do to figure out if it's divisible by that number. So because it's divisible by 3, I'm actually going to right away, no, that's not 50, is that 57? Yeah, 57. 57 over 100. I can make an equivalent fraction to 171 over 300 without having to do division. Because once I have it that way, I then read it as, I won't write it as words, I'll write it as numbers. I read this as 57 hundredths, right? Which means I would then write it as 0 decimal. And again, of these 3 place values, this is your hundredths because this is your tenths, this is your hundredths, this is your thousandths. So 57 has to end in that hundredths position. So as a decimal, I'd have 0.57. Okay? And the nice thing is this fraction, this equivalent fraction, also helps me get my percentage because 57 out of 100 would be 57%. Okay? Now, if you wanted, you could have taken 171 and divided it by 300. Right? You could have done that method that we talked about in the last question. If you did that, 171 divided by 300 would have given me 0.57, which is 57 hundredths, which is 57%, right? We could have done it the way from the first example, but I just wanted to show you that there's a second way you could have done it without division. And in the third question, you have 88 fiftieths. Okay, 88 fiftieths. Change that to a decimal and a percent. Well, if you have an improper fraction, You could do the first way, and you could go 88 divided by 50. And if you took your calculator and did 88 divided by 50, 88 divided by 50, you would get 1.76, which is 1 and 76 hundredths, which is equal to 176 hundredths, which is equal to 176%, right? Because you're dealing with something more than 1, it's going to be more than 100%. Since this fraction is greater than 1, we know that my answer has to be greater than 100%. But the second way you could have done it instead of that method, you could have said, well, 88 fiftieths as an equivalent fraction out of 100, right? I'd multiply both by 2, would be 176 out of 100, which is 176%. We know that right off the bat. But more importantly, it's also 1 and 76 hundredths. So I was able to get my answer, that's the fraction, that's the percent, without using division, right? I was able to do it using equivalent fractions, okay? Now the other way you could have done it is you could have just changed it from 88 fiftieths to 1 and 38 fiftieths, which is the lowest term. No, it's actually not even lowest terms, which is 1 and 76 hundredths, which is 1 and 76 hundredths. So there's actually 3 different ways you could have done it if you wanted to. All right, the second question gives you the decimal this time, not the fraction. It gives you the decimal and asks for it as a percent and a fraction. So for A, we're going to say this is 0.0064. Now, if I say what number is that, you say, well, it's 0.0064. No, that's not the number. That's how you would read it to a person who didn't see the number and they wanted to make sure they wrote it correctly. This number is actually, this is the tenths, this is the hundredths, this is the thousandths, this is the 10,000ths. And again, like I told you before, if you cover up the decimal and read that number, that's 64. And the last place value is 10,000, so it's the 10,000ths. So as a fraction, it's 64 10,000ths. Now, once we have it in fraction form, again, because that denominator is a base 10, I will always be able to take it to an equivalent fraction out of 100, which is what this percent is. So 1,000 divided by 100 is 100, and 64 divided by 100 is 0.64, which therefore, since percents are out of 100, would be 0.64%. And just to keep this in mind, this is less than 1%, right? Just a little bit more than 0.5%, but less than 1%. For the second question, it's 0.268, which is 268 tenths, hundredths, thousandths. So 268 thousandths is how I would properly read that, which has an equivalent fraction out of 100 to make it that percent. I would divide 1,000 by 10 to get 100. And when I divide 268 by 10, I get 26.8. Remember, when you divide by 10, all you do is move the decimal over one place. So therefore, that would be 26.8%, right? And the third question, 5.98. So we know we're dealing with a number greater than 1, which means I know that it's going to be greater than 100%, because this is a part of 1, which means it's a percentage of a whole, less than 1 of it. But this one is going to be 5 and 98 hundredths is how I would read this number. 5 and 98 hundredths as a fraction would be 5 and 98 over 100, which is 598 over 100 as an improper fraction. This is mixed, this is improper, which would be 598%. All right, and your last one, you're given the percentage this time, and you're asked to change it to a decimal and a fraction. So the first one, 750%. Because it says percent, the first thing you want to do is take this number and put it over 100, because that's what a percentage is. It's out of 100. And once you have it as that fraction, you can then change it to 7 and 50 hundredths. This is improper to mixed, which in lowest terms would be 7.5. So 750% as a number would be 7.5. And as a decimal, I can actually use this one to make the decimal. 7 and 50 hundredths is what that would be read as a decimal. And since this 0 is not really necessary, I could say or 7.5. And why? The reason why we say that 0 is insignificant is if I think of this 7 and 50 hundredths, I could think of it as 7 and 5 tenths, right? Those are equivalent fractions. And 7 and 5 tenths is this number here, right? So you could think of it as 7 and 50 hundredths, or not in those terms, but in without the insignificant 0, 7.5. In B, we have 0.3%. So the first thing you want to do, that's the worst equal sign. First thing you want to do is, because it's a percentage, put it out of 100 and take this number and place that over 100. So that's 0.3% written as a fraction. Now, because I have a decimal in the numerator, we want to eliminate that somehow. So in order for me to get rid of that decimal, I really have to multiply it by 10 to move it one place over. So if I multiply this by 10, I get 3. But in order to keep it equal, I have to multiply that by 10. So an equivalent fraction to 3 hundredths would be 3 thousandths, which as a decimal, tenths, hundredths, thousandths, there's where the 3 goes. These place values have to have 0, so my answer is 0.003. That's decimal 3%. And your last one, C, is 12.75%. Now, when you're given a fraction, a percentage, that has a decimal in with the whole number, the first thing I want you to do is rethink that as being 12 and the fraction part as a decimal. So 12.75% and 12.75% are the same thing. So the first thing you should do is convert it to a decimal. And then as we did up here, start thinking about it as a percent. So because it's a percent, I want to put my denominator as 100. My numerator would be 12.75. That is 12.75%. Now here, I have a decimal in my numerator, but I need to get rid of it. But I have to move it twice to get rid of it, which means I'm going to multiply by 100 to get rid of that decimal. I'll get 1275 over, and when you multiply by 100 with no decimal, you're moving it 2 places, or technically you're just adding 2 zeros. So you get 10,000, which means this number here is 1,275 ten-thousandths. So if I put my places out here, this is tenths, this is hundredths, this is thousandths, this is 10,000ths. So that's where the 5 has to end, and I get 1,275 ten-thousandths. Okay? Hopefully that helped you.